Hi everyone, in this video we are going to see how to find the equation of the image of a given circle when reflected on a given line. That means we will be given the equation of a circle and the equation of a line, and we have to find out the equation of the image of this circle if we assume that that straight line is nothing but a line mirror. Let's suppose we have a circle like this whose equation is given as x squared plus y squared plus 2gx plus 2fy plus c equals 0, and from there we can easily say that the location of the center would be negative g comma negative f, and the radius of the circle would be square root of g squared plus f squared minus c. Also, we have been provided with the equation of the line mirror, and the equation of that line is ax plus by plus c equals 0. Here a, b and c, they all are in uppercase, and in the equation of the given circle the c is in lowercase, the constant term is a lowercase c, and in the equation of the straight line the c is in uppercase c. According to the law of optics in physics, we know that each and every point on this circle will be at the same distance from the straight line on the other side of the line when reflected on this mirror. That means the radius of this circle will remain same in the image. That means the radius of the image will be same as the radius of the original circle. The only thing that's going to change is the center of the circle. Now the center of the image is nothing but the reflection of the center of the original circle on this line mirror, right? So we have to find out what is the location of the center of the image, but the radius will remain same, and once we are able to find out the coordinates of the center of the image, we should be able to easily determine the equation of the image of the circle. Now if I have to draw the image of this circle when reflected on this given line, then the image could look something like this. And here I have noted that the center of the image is located at h comma k. So let's assume that the x coordinate of the center of the image is h and the y coordinate is k. And also I have noted that the radius of the image will be same as the radius of the original circle. And obviously we have to find out the values of h and k, and then we should be able to formulate the equation of the image. In a previous video, we have discussed about how to find the coordinates of a point when reflected on a given straight line. I have shared the link in the description. Feel free to watch that video. According to the formula in that previous video, we have seen that the x coordinate of the image can be written like this, and similarly the y coordinate of the image will be like this. So now we are going to use this formula to find out the values of h and k. And in this example, x sub 2 is actually h and y sub 2 is actually k. So the values of h and k can be noted like this. In the formula, wherever we had lowercase a, I am using uppercase a because that's what I have used in the equation of the given straight line. Similarly, lowercase b has been noted as uppercase b and lowercase c has been noted as uppercase c here. So using this formula, we should be able to calculate the values of h and k. Now once we have the values of h and k, then finding the equation of the image is pretty easy. We know the equation of any circle can be written as x minus h whole square plus y minus k whole square is equal to r square, where h and k are the coordinates of the center. So in this case, when we are talking about the image of the original circle, what are the coordinates of its center? Well, that's h and k that we have assumed. So we can write the equation exactly like this, and then we can plug in the values of h, k and r in this equation to find the final form of the equation of the image. Next, I am going to take an example. Let's suppose we have an example like this that says find the equation of the image of the circle whose equation has been given as x squared plus y squared plus 8x minus 16y plus 71 equals 0 when reflected on the straight line whose equation is given as x minus y plus 2 equals 0. So let's try to solve it. The equation of the given circle is like this, and if we compare that with the general form of the equation of a circle, from here we can say 2gx is equal to 8x, that means g is equal to 4 and negative g will be equal to negative 4, and similarly 2fy is equal to negative 16y, and from here f is equal to negative 8, and then negative f is equal to positive 8. Also let's calculate the radius of this circle. We know radius is equal to square root of g squared plus f squared minus c, and now let's plug in the values, and as you can see the radius turns out to be 3 units. So I have made a note of that, r is equal to 3. So using the calculated values of negative g and negative f, let's try to find out the values of h and k, I mean the coordinates of the center of the image. Here is the formula for h, and similarly the formula for k will be like this. Next, we are going to plug in the values of G, F, A, B and C to find the values of H and K. Now, if we compare the equation of the straight line with the general form of equation of a straight line, then let's quickly find out the values of uppercase A, B and C. I am noting it on the top right corner there. So, from the given equation, we can say A is equal to positive 1, B is equal to negative 1 and C is equal to 2. So now let's plug in the values here. In the formula for the value of H, I have plugged in the values of G, F, A, B and C, and let's try to simplify it, and the value turns out to be positive 6. Similarly, let's calculate the value of K, and here looks like the value of K is equal to negative 2. So now we have everything we need to formulate the equation of the image of this circle. We have the coordinates of the center of the image and also we have calculated the radius. So now let's formulate the equation. We are going to use the general form of equation of any circle, which is x minus h whole squared plus y minus k whole squared is equal to r squared, and here let's plug in the values of h, k and r. So the equation will look like this, and then if we expand and simplify, the equation going to look like this, and if we rearrange the terms and bring everything to the left side, the equation is going to look like this. So that is the equation of the image of the given circle when reflected on that given line. I hope the steps in the derivation made sense. Thank you for watching. See you in the next video.